Hi, welcome back to Maths Learning Groups. Now today we are going to look at MGS, which is SA1 2019. So we are going to go through the entire paper 1 to help you to revise your basic understanding of the different topics. How to benefits from the lesson is that you have to do the paper first. Right? You have to attempt to do the paper, answer the questions, and once you have completed the paper 1, then you look at the video to watch the lesson and to revise your mistakes. So that's the best way to benefit from the lesson. Alright, so let's go straight into our lesson proper, and let's go to question 1. Okay, now, the value of the digit 5 in 650,841 is what value? So you look at the digit 5, which is in the 10,000 place. So that will be 5 10,000. So 5 10,000 will be 50,000. So your answer will be number 4. So the first question is always the easiest in the exam. Okay, now next one, your 4 operations. So when you have 4 operations, so which one must you do first? You have to look out for the brackets. So if you see a bracket, that is what you must do first. So you have 4 plus 5 times 60 minus 30, that will give you 30. And then I think that's a plus, okay, that's a plus 10. Okay, and then you have plus, times, and plus. So which one do you do first? You do the times first, which is more important than plus. So you have 4 plus 150, and then plus 10. Okay, so now you have plus and plus, so they are equally important. So you do left to right. So you have 4 plus 150, which is 154, and then plus 10. And what's the answer? Your answer will be 154. Oops, there's no answer in the options. So I think there must be something wrong with the answer key, right? Something wrong with the question. So since there's no answer, then let's put our own answer there. So your answer will be 154. Okay, sometimes when you do the school papers, you might have some mistakes, right, in the printing or in the question. So, but anyway, so for question 2, so we will just correct our own mistakes, and you can see that your answer will be 154. Okay, so let's go on to question number 3. A number becomes 60,000 when rounded to the nearest thousand. So which of the following could be the number? So how do you round to the nearest thousand? Now, you just draw a line to show the last 3 digits. Because nearest thousand have 3 zeros. So you draw a line to show the last 3 digits, and you look at the digit nearest the line. Is it 5 or bigger? It's not 5 and bigger. So your nearest thousand is still 59,000. And you do the same for the rest of the numbers. So for answer 2, draw a line and look at the digit nearest the line. And it's 5 and bigger. So you have to add 1 on the next digit. And the nearest thousand will be 60,000. So which number when round off to nearest thousand is 60,000? So your answer will be number 2. And you don't have to see number 3 and number 4 already, because your answer is number 2. Okay, let's go to question number 4. Which one of the following is not the same as 4 over 9? So let's look at number 1. Now 4 divided by 9, can also be written as a fraction, which is 4 over 9. So your fraction is also dividing. The fraction line is your dividing line. 4 over 9 is 4 divided by 9. So this is the same. And how do you multiply fractions? So you take 1 times 8, and then 2 times 9. 18. Okay? But however, instead of shortcut to do this, you cancel the numbers to make the numbers smaller. Then you can do faster. So divide by 2, and you get 1. And then 8 divided by 2, you get 4. And then you multiply the numerators, 1 times 4, and then 1 times 9. Oh, also 4 over 9. So put a tick there. What is 9 divided by 4? 9 divided by 4 is actually 9 over 4, which is not the same as 4 over 9. So your answer has to be number 3. Okay, then how about number 4? Now, how do you multiply whole number with a fraction? You change the whole number into a fraction, improper fraction. Then you take 4 times 1, multiply the numerators, then you multiply the denominators, and you still get 4 over 9. So your answer has to be number 3. Okay, let's go to number 5. Express 5 and 3 over 7 as a decimal correct to 2 decimal places. Alright, now, so this will test you on your dividing, how to divide to get decimal. So first step is to change it to an improper fraction. So you have 5 times 7, 35, then 35 plus 3, 38 over 7. So you are tested on changing the mixed number into an improper fraction. And then after that, how to get your decimal? 38 over 7 is also 38 divided by 7. Okay, then you do your working. 5 times 7 is 35, you get remainder 3. Alright, but you want 2 decimal place, so you have to continue to divide. Change the whole number into a decimal. Bring up the decimal point, pull down the 0, and then you have 4 times 7 is 28. Oops, something seems to be dropping down. Okay, what is that? Okay, so let's try again. So 4 times 7 is 28, and then you minus, you get 2. And how to continue dividing? You add one more 0, and you pull down the 0. And then you have 2 times 7 is 14, and remainder 6. Alright, one of the common mistakes that students will make is they stop over here because they got their 2 decimal place already. But you didn't correct, you didn't do any rounding off. So you have to get your answer in 3 decimal place, then you round off to 2 decimal place. So you can't stop here. You have to keep dividing. So you put down another 0, and then you have 8 times 7 is 56, and then you can stop dividing already because your working answer is 3 decimal place. Then how do you correct to 2 decimal place? You draw a line to show how a 2 decimal place look like, and you look at the digit nearest the line, which is 8. Is it 5 and bigger? Yes. You add 1 on the next digit. So your 2 decimal place will be 5.43. So answer will be number 4. Okay? And that's how you correct the 2 decimal place. So this can be quite easy, but can also be quite hard if you don't know how to divide to get decimal. Okay, now question 6. How do you get the simplest form? So 27 out of 36, you divide by 2, but you can't. So divide by 3. Why cannot divide by 2? Because 27 cannot divide by 2. So you have to divide by the next number, which is 3. You get 9 over 12. And then divide by 3 again, and you will get 3 over 4. So your simplest form will be 3/4. Okay? Alright, question number 7. Now what is the difference between these 2 fractions? So now you're tested on how to minus the fractions. So you have 7.5 minus 2 3/4. So the denominators are different, so you have to make them the same. So you take 7 2/4 minus 2 3/4. And then there's a problem because 2/4 cannot minus 3/4. So you will have to borrow. Okay, borrow 1 whole from 7. And when you borrow 1 whole, you have 6 wholes left. And the 1 whole that you borrowed become 4/4. So 4/4 is your 1 whole. So 4/4 plus 2/4, you will get 6/4. So that's how you borrow. And then you minus 2 3/4. So how to minus? You minus the whole numbers. 6 minus 2, that gives you 4 wholes. And then 6/4 minus 3/4, you will get 3/4. So the difference is 4 3/4. Answer number 1. Okay, question number 8. Working backwards. Right? How do you get the answer, the blank box? You work backwards. So when you work backwards, the minus become plus. So every time you see a sentence like this, and the front box is missing, or the front box is empty, then you must remember to work backwards. So you take 2 1/4, and the minus become plus 5 over 6. And denominators are not the same. So you have to make that the same. And also try not to 4 times 6, 6 times 4. Try to find something smaller. A common denominator that is smaller, which is not 24, which is 12. Because if you have a smaller denominator, then it will be easier to work out the answer. And if your numbers get bigger, then what happens? That you will need to more. It's harder, right? When the numbers are bigger. So you times 3, and then you times 2. So what is your equivalent fraction? You have 2 3 over 12 plus 10 over 12, and then you will get 2 whole plus nothing. You will get 2 wholes, and then 3 over 12 plus 10 over 12 will be 13 over 12. So this is a very funny mixed number. So you will have to take out 1 whole from 13 over 12 because it's improper fraction, right? So you take out 1 whole, and 13 over 12, you take out 12 over 12, and it becomes 1 whole. So you will have 3 already, 3 wholes. So when you take out 12 over 12, that will be how many left? That will be 1 over 12 left. So your fraction will be 3 and 1 over 12, right? So that's how you take out 1 whole, right? Take out 1 whole, and then what is the leftover? That will be 1 over 12. 13 over 12 minus 12 over 12, you get 1 over 12. So your Your missing fraction is 3 and 1 over 12. Okay, next one. So which of the following is the same as 3 times 2 over 7? So what do you mean by 3 times 2 over 7? It means that you have 3 groups of 2 over 7. Okay? Every time there's a times, it means that we are talking about groups, 3 groups of 2 over 7. So that will be 2 over 7, that's one group, this one group, so you plus another one group, plus another one group. So which means that, okay, so what is the answer there? So 3 times 2 over 7, so how do you multiply to get your answer? Okay, let me just write again, so that, okay, like this. 3 times 2 over 7 will be, you change the whole number into a fraction, and you get 6 over 7. Okay, so which answer is 6 over 7? Definitely not number 1. Okay, because that gives you a whole number, an answer that's a whole number. Alright, is it number 2? 3 times 2 is 6, right, 6. And then 6 times 1 over 7. So what is 6 times 1 over 7? So you change the whole number into a fraction, and then you multiply the numerators and multiply the denominators, which is 6 over 7. So your answer will be number 2. So number 2 is the same as 3 times 2 over 7. Okay? And of course, number 3 and number 4 don't have to see already. You got your answer, number 2. Okay, let's go to number 10. So you have a ratio, and to get the missing number, you always have to get the simplest form. Right? Get the simplest form. And use the simplest form to get the missing. Right? To get the missing number. So you divide by 3. Okay, now you can try to think of a bigger number so that you can do faster. But otherwise, you divide by 3, divide by 3. But I think I can have a bigger number. I divide by 9, and then I can do a bit faster. Because remember, paper 1 is a 1 hour lesson, a 1 hour exam. So you can't have too much time to do a lot of working. So you have to work smart. You have to try to do a bit faster using shortcuts if you know of any, so that you can do faster and still have some time to check. So you divide by 9, and you get 2 is to 3. So once you get the simplest form, you can use that to find the missing number. So 2 times 4, and then 3 times 4. And your missing box is 12. Right, so answer number 4. Okay, now we come to the 2-mark question. So you have Ravi and Paul were given a sum of $56. Ravi received $32. What was the ratio of Ravi to Paul's share? Okay, so if the total is 56, Ravi gets 32, then you can find Paul. You take 56 minus 32, and you will get 24. So Paul has $24. Now the important lesson here for this simple question is the order. That you need to write the ratio in the correct order. So what comes first? Ravi comes first. So 32, then Paul comes later, which is 24. So 32 is the 24. And work smart, try not to divide by 2. Try to divide by multiples of 2 so that you can do faster. How about 8? So divide by 8, you will get 4 is to 3. So the ratio is 4 is to 3. Answer number 3. Okay, that's your ratio problem. Okay, question number 12. And Cindy bought some cupcakes from a shop. For every 10 cupcakes that Cindy paid, she received another 2 cupcakes free. Now immediately, methods comes in. Right, so to do well for your paper 2, you will need to know some methods like assumption, what else? Grouping, model drawing. All these are methods that can help you to solve problems for those hard problems. So when you come to this question, what is a method that we can use? There are some keywords, there are some word clues that you can look at to think about the method that is suitable to be used. And one of the clues that we see is the word every. So for every 10 cupcakes, there is one group. So the method that we want to use is grouping. Right, grouping, because I can meet one group with 10 cupcakes. So how do I use the method? So I meet one group and pay. Let's label. So Cindy paid for 10 cupcakes, and she will get 2 cupcakes free. So I label 2, right? And the total cupcakes in one group will be 12. So I meet different kinds of one group, and Cindy had a total of 240 cupcakes in the end. So how many free cupcakes did Cindy receive? So you have to find how many groups are there in 240 cupcakes. So you go back to one group and look for the same thing, look for the total number, because the 240 cupcakes is talking about the total cupcakes. So you go back to one group and you look at the total, which is 12. Then you take 240 and you divide by 12. And what's the shortcut to divide? You cover the 0. 24 divided by 12 is 2. And you put back the 0. So you will get 20 groups. 20 groups. And if there are 20 groups, and how many free cupcakes did she receive? Then you go back to one group again and look for the same thing. You look for the free. There are 2 free cupcakes. So if there are 20 groups, then 20 times 2. So she must have received 40 free cupcakes. So answer number 3. So there's a method over here which is called grouping method. Okay, let's go on to the next one. Question number 13. Okay, ratio again. And every time there's a ratio problem, there's an age problem, then you have a define after. So it's quite easy to recognize that if you have an age problem, then usually there's a define after, and what is unchanged? The age difference is unchanged. Okay, and there's a method that I want to show you, which is a table method. So every time there's a before and after. Okay, so I don't usually show this. I don't teach this nowadays because some schools, they don't recognize it. And because they don't recognize it, so they may penalize the students. So I don't usually show this. But it's actually very good. It's a good method that replaces model drawing. So if there's a before and after problem, then this method, I call it the table method. And it's quite easy to use. So you have Henry to uncle to total, right? Total age. And what is unchanged? The difference is unchanged. So I can actually put a column here for the difference unchanged. And what I do is I just put the numbers into the table. So Henry age is 3:5, total is 8, and the difference is 5 minus 3, 2 units. So the ratio, I call them units. So what I have actually done is to put the ratio into boxes. And Henry is 30 years younger than his uncle, right? There is a difference, which is what? Which is unchanged, right? So how old is Henry's uncle? Oh, this is not a before and after. Okay, it's not a before and after, so we don't need the table. Okay, so I saw the question a bit wrongly. So this is not a before and after problem. It's a very simple problem, so we can actually solve already. So which means that your 2 unit is 30. Okay, let's continue. Alright, and your 1 unit is 30 divided by 2. Your 1 unit is 15. And how old is the uncle? The uncle is 5 units. So 5 units will be 15 times 5, 75. So the uncle is 75 years. Okay, so I didn't really see carefully. So if this question is a before and after, then what is the method that I would like to use? I will use the method called the table method. But like what I mentioned, schools don't really do this. Okay, they don't really do this method. Some schools, they do that. But what is the most common method that we do? Ratio method, right? Using ratio to represent without a table, or using model drawing. But you don't really see this. You don't really see this method being used in schools. But it doesn't mean that other schools are not doing. Alright, because I have some students whose teachers are doing something like this. Alright, so it all depends on what your teachers are doing in the class. Okay, so this is not a before and after problem, so I can't use a table method. But it's a very easy question to solve. So let's go on to the next one. Now, there's a remainder problem. There's a fraction problem. There's a remainder problem. So immediately, what's the method? The method is model. Okay, or some students will use branching. Okay, branching. But I don't really do branching because branching is not visual, right? It's hard to see visually. When you draw the model, you can actually see more visually. So let's draw the model. So Mrs. Ting has some money. She used 1/5. So what does this fraction, what is it talking about? It's talking about it, which is the money that she had. And this fraction is talking about what? It's talking about the remainder. So are the two fractions talking about the same thing? They are not talking about the same thing. So you can't make the denominator the same. So every time you see fraction problems, you will need to ask, are the fractions talking about the same group? So if they are talking about the same group, then you make the denominator the same. But if they are not, then you don't make them the same. But we can still draw the model. So 1/5 is talking about the money. So you draw a rectangle for the money. And you cut the rectangle into 5 boxes. And one box is used to buy a skirt. Where's the remainder? The rest of the boxes. And the remainder, you have to cut into 3 boxes. But if you look at the model, there are 4 boxes. So it's a bit hard to cut into 3 boxes. So what do? You can actually drop down the remainder and cut into 3 boxes, like this. And 2 boxes are spent on a bag, okay, on the bag. So you label bag. And then where's the left? This is the left, which is the 1 box left. So what fraction of the money has she left? Okay, if you look at the model, you can see that the boxes are different sizes. So you have to make them all equal. So to make them equal, it's very easy. The remainder has 4 boxes on top. So you just cut into 4 units. And the remainder has 3 big boxes below. So you just cut into 3 units on top. And if you add the units, you will see that there are 12 units on top and there are 12 units below. And over here is also 3 units. So what fraction of the money? So where is the money? The money is this whole rectangle, which is 15 units. And how many units has she left? Which is your 4 units left. So your fraction is 4 over 15. Okay, and that's how you get your answer, number 2. So compare branching with model drawing. So which is actually easier? I would think that model is easier because it's more visual. Branching is a little, branching has its limitation because you can only do branching for remainder problems. But when it comes to something harder than this problem, then branching will be a bit hard to use already. But model drawing is very flexible. You can use model drawing for many kinds of problem, right? So model drawing is still, I would think that it is still more preferred than branching. Okay, let's go on to the next question. Okay, now question 15, your triangles. So how do you find the area of the shaded triangle? Now, if the shaded triangle or the shaded area is a regular shape, so what is a regular shape? Squares, rectangle, triangles. So if they are regular shapes, there's no need to apply any methods. You just have to apply the formula, which is half times base times height. So what's the base? Okay, so first of all, you will have to know what triangle you're looking at. So the base will be 18 minus 10, which is 8. And the height is right angle to the base. Okay, and the height will be how long? 24 minus 5, that will be 19. So what's the shortcut to do this, to find the area? So you always have the half in front, and the base is 8 times 19. Okay, there is a shortcut, or rather, your teacher will have taught you to cancel, which is important. Because if you don't cancel to make the number smaller, then you have to calculate, you have to work out, do more working. So when you cancel, you make the number smaller and you reduce the working. So 2 divided by 2 is 1, 8 divided by 2 is 4. So now all you have to do is just take 4 times 19, which is 1 step, and you get your area, which is 76 centimeters square. So cancel is a shortcut that you need to learn, right? And that's what many schools teachers are doing. So you need to know how to cancel to make the number smaller. Okay, next one. Let's go to your open-ended problems, which is the 1 mark question. So this can be quite easy, but it can also be quite hard because it's a very big number. So your 2 million. So how do you write 2 million? Millions have 6 zeros. And then you have 53,000. So you break up the words into numerals. And then 17, and you put 17. Then you plus them together. Okay? And you will get your figure. So you have 2 million and 53,000 and 17. Okay? So that's your numeral. Okay, next one. Find the value. Okay, shortcut again. There's a shortcut over here. So when you multiply numbers or when you divide numbers with zeros, there is a very simple shortcut. You take 6,000 times 350. All you have to do is just cover the zeros. Okay, cover the zeros. Don't look at the zeros. And you have 35 times 6, and that will be how many? 35 times 6. Okay, do your working, but let me use my calculator so I can do a bit faster. And you'll get 210. And you covered 4 zeros. So you just have to add 4 zeros behind. So what is the answer? Your answer will be 2,100,000. Okay, that's how you do very fast. You cover the zeros and then later you put back the zeros. Okay, the next one. And how do you multiply the fractions? Again, cancelling. So you divide by 5, you get 1. 25 divided by 5, you get 5. 6 divided by 3, you get 2. 9 divided by 3, you get 3. And then you multiply the numerators, which is 2 times 1 and 5 times 3. And that's your simplest form. So when you cancel, you are also simplifying the fraction. Because if you don't cancel, you will have to simplify later on. So might as well you cancel now, so that you don't have to simplify later. Okay, so let's go on to question 19. A dining table has a mass of 31 kg. It means the table, 6 times as heavy as the chair. So what's the mass of the chair? So which means that the table is 6 times or 6 unit, and the chair is 1 time, right? So what should you do? So if 6 unit is 31 kg, then you just find 1 unit, you take 31 and divide by 6. Okay, now over here, you can do very fast if you don't change into decimal, if you don't convert to decimal. So for example, the question number asks you to write in decimal. So all you have to do is just take 31 divided by 6. So 5 times 6 is 30. What happens if you continue to divide? Then you are giving yourself more work, because the question number tells you to write to 2 decimal place or to write as a decimal answer. So you just have to write as a fraction, which is very fast. Okay, so once you get your remainder, then what's the mass of the chair? 5 and 1 over 6 kilogram. So leave your answer as a fraction, and that's how you do very fast. If you were to continue to divide, it gets a bit risky, because you may make you may divide wrongly, and then your decimal may end up to be the wrong answer. Alright, so if the question never asks you to convert to decimal or never asks you to write in decimal place, then what should you do? Then you should just write as a fraction. Okay, next one, question 20. The solid figure or the solid shown is made of identical 1 cm cube. So what do you mean by 1 cm cube? It means that every side of the cube is 1 cm, right? Every side of the cube is 1 cm. So can you find the volume of 1 cube? So the volume of 1 cube is 1 cm, length times height, and you get the volume of 1 cube, which is 1 cm cube. Okay, so what is the volume of the whole solid? So you will have to count the cubes that make up the figure. So there's a way to count it, right? There's a way. So what's the way to count it? You count the cubes in columns. Okay, for example, this is 1, 1, 1, 1, 1, 1. So you just put the number on top. Alright, you look at the column behind, there are 3 cubes in the pillar, in the column. So just put 3. And then you have 2 and 2. So what is the best way to count the cubes? Is to count when they are standing. Count them standing. Or count them in the pillar. Some teachers, they count layer by layer, which is also possible, right? But I think when you count by column, when you count downwards, when you count by columns, it's actually easier than counting by layers. Okay, so how many cubes make up the solid? So you have 1, 2, 3, 4, 5, 6, 8, 10. 10 plus 3, 13. So there are 13 cubes. Okay, now the common mistake that many students will make is they put the answer as 13. But this 13 is talking about the number of cubes. But you're asked to find the volume, right? So if it's a paper 2, the unit sign is not given to you. So if you put down 13, your answer is wrong. So you will need to take 13 times the volume of 1 cube to get the volume of the solid, which is 13 cm cube and not 13. So there's a difference between 13 and 13 cm cube. Right, 13 refers to the number of cubes that make up the figure. 13 cm cube is the volume. Alright, so there's a big difference. Okay, let's go to question 31. A rectangle measures 12 over 5 meter by 8 over 9 meter. So what's the area of the rectangle? And give your answer as a mixed number in the simplest form. So you are tested on how to multiply fractions. So you have to cancel again. So you divide by 3, you get 3, divide by 3, you get 4, and you can't cancel anymore. So you multiply the numerators, 4 times 8, 32, and then 5 times 3 is 15. So how do you change it to a mixed number? Then you will have to take 32 and divide by 15. So every time you see a fraction, it means divide. Okay, 32 over 15 means 32 divided by 15. And so you have 2 times 15, you get 30, and that's a remainder 2. And how to get the mixed number? 2 and 2 over 15. So your mixed number is 2 and 2 over 15 meter square, which is the area of the rectangle. Alright, so not that hard, right? Not that hard for so far. Okay, question 22. Now, Mr. Low participated in a 10-kilometer marathon. He ran 4 2/3 kilometer for the first part. So what is the distance he will have to complete? Right, he has to run to complete the marathon. So the total distance is 10 kilometer, which is 10 holes. So every time there's a fraction in the problem, then the whole number is your holes, 10 holes. Okay, 10 holes, and he ran 4 2/3. So you have to minus 4 2/3 to find how much more he had to run. So how do you minus whole number with fractions? You have to take out one whole, and you have 9 holes left. And the one whole becomes a fraction with the same denominator, which is 3 over 3. And then now you can minus minus 4 and 2 over 3 kilometers. So you take the whole number minus whole number, you get 5 holes. 3 minus 2, that will be 1/3. So you have 5 and 1/3 kilometer left to run. Okay, so that's how you minus fractions with whole numbers. Okay, let's go to question 23. Oh, fractions again. Very good question, right? This is a very good question because most students, they will be stuck at this question. So every time you see fraction problems, what do? You think about what are they talking about. Like for example, what is this fraction talking about? Them. It's talking about them. And what is them? Which is all the pupils. And then what is this fraction talking about? The girls. So are the two fractions talking about the same group? They are not talking about the same group, so you cannot make the denominator the same. Then what is the method for this problem? Model drawing. Because every time you see fractions, the first method that will come to your mind has to be model drawing. So we draw a rectangle, you look at 3 over 8, which is talking about all the pupils. So you draw a rectangle, which is the word them, which is all the pupils. So you look at the fraction and you draw the rectangle, which is what the fraction is talking about. And you cut this rectangle, which is all the pupils, into 8 boxes. And you need to do arrow pointing in order to know how to cut. So the denominator is the total boxes to cut. And 3 boxes are boys. Okay? And then you label. And then of course the rest are girls. Okay? Alright. And then you can see that the girls must have 6 boxes. But if you look at the model, there are 5 boxes only. So you cannot cut into 6 boxes. Then you have to drop down. Right? I'm sure your teacher will have taught this also. So if you cannot cut the remainder into 6 boxes, then you drop down and then you cut into, now you can cut into 6 boxes already. So 1, 2, 3, 4, 5, 6. And one box wears spectacles. Okay, one box of the girls wear spectacles and the rest of the girls, they don't wear. Okay, so how many girls wear spectacles? Alright, so we need to complete the model. So there's a total of 1632. Alright, and how many girls wear spectacles? That's the question mark. And that's your model. And once you've done your model, you can solve already. Because you look at the model, you can see that there are 8 boxes, which is 1632. Okay, so 1632 you can divide by 8, and you do your working, and you will get 204. So every box here is 204. Right, so I'm going to just put something like this. And then how many girls do you think there will be? So there are 1, 2, 3, 4, 5 boxes of girls. So you take 204 and you times 5, and you will get 1020 girls. And if there are 1020 girls, then the model below has to be the same also, right? Because what's on top and what's below is the same. So you have 1020 girls at the bottom. And how many boxes are there? There will be 6 boxes, which is 1, 2, 3, 4, 5, 6. And you take 1020 and then you go and divide by 6 to get how many girls wear spectacles. And you do your working, you will get 170 girls wear spectacles. So this is your 170. And you got your answer, right? Using model drawing. So your answer is 170 girls wear spectacles. So what's the lesson here? Now the lesson here is to draw a model. Okay, when you see fractions, alright? And because it does help you to to solve a bit faster. And of course, you can also use branching if you know how to use. Okay, but otherwise, model drawing will be the alternative. Okay, let's go to question 24. Okay, Ali bought 2 3/4. Okay, let me just double check to see that we have done all the questions already. Okay, question 24. So Ali bought 2 3/4 meter of ribbon. A meter of ribbon costs $8. So how much did he pay for the ribbon? So you have to times. So 1 meter is $8. Then 2 3/4 meter times 1 meter is $8, right? So how do you multiply? Now you cannot multiply mixed number with whole numbers. It's very hard, right? And it will be very dangerous. So you must change the mixed number into improper. So 2 times 4, 8. 8 plus 3 will be 11/4 times $8. Okay? And then you change the whole number into a fraction. And then you cancel, divide by 4. 8 divided by 4. And then you multiply the numerators. And you multiply the denominators. And how much is that? That will be $22. Okay? So lesson here is what? You can change the mixed number into improper fraction and then you multiply. Alright, some of you you take 2 wholes times 8 and then later 3/4 times 8 and then you plus them together, also can, but it's a bit more risky. Alright, unless you're very sure how to do it. Otherwise, I will advise you to change it to improper fraction and then just multiply. Okay, question 25. Triangle again. So what's the area of triangle CDE? You got to highlight the triangle that you are looking at, which is CDE. So this is the triangle that you are finding. So how do you find the area? Then you must remember your formula, which is half times base times height. So the base is one of the 3 sides of the triangle, all the 3 sides. And the base is always right angle to the height. So if you see a square box, then you know the base is somewhere there, right, somewhere nearby. And the height is also somewhere nearby. So the base has to be one of the 3 sides. Alright, cannot be 12 meter. 12 meter cannot be the base, because where are the 3 sides of the triangle? So the base can be this one, can be this one, can also be this one, but cannot be 12 meter, because 12 meter is not one of the 3 sides of the triangle. So the base has to be over here. Alright, because there's a right angle box and it's perpendicular to the height. So the base is 9 plus 5, that is 14, and the height is 12 meter. Alright, so again, you must know how to cancel. So you divide by 2, and 14 divided by 2, and then you take 7 times 12, you get 84. So the area of the triangle is 84 meters square. Okay, so that's how you find the area of the triangle. Okay, let's go to the next one. Okay, the next one. And question 26. The figure is made of 10 unique cubes. So can you draw the top view? Alright, now there is an important lesson here. When you draw the top view, there's only one answer. There's only one drawing. So how should you draw the top view? You have to stand in front. Always stand in front. Means you always face the front, then you look down. And when you look down, you will see 2 squares, and 2 squares, and 2 squares. So you have 2, 2, 2, right? 2, 2, 2. So when you draw your top view, it will be using rulers. Okay, using rulers, it will be 2 by 2 by 2, right? 2 squares, 2 squares, and 2 squares. So you have 2 by 2 by 2. Okay? And then some teachers will advise you to color. But usually I will just do dark shading. I will just draw some lines to show the shading so that we can do a bit faster. Okay? Alright, next one. And how do you draw the front view? Now the front view, you look in front, you will see 3 squares on the left side, and then 1 square in the middle, and 2 squares on the right. So 3, 1, 2. Okay, 3, 1, 2. And then you go back to the picture, 3, 1, 2. So you have 3, okay, and then 1, and then 2. Alright, something like this. Okay, I'm not using a ruler, so you will need to use a ruler to draw the lines. And your lines must cut through the dots. And you also need to show the squares clearly. Show the square, the outline of the squares. Okay, don't show the perimeter. You have to show the square boxes. And of course, do some zebra stripes to show the shading. Okay, that's your front view. Alright, and so it's not a very hard question over here. So you will need to score in this question because not that it's very easy to get your marks from this type of question. Okay, let's go to the next one. Okay, now it gets a bit hard already. Okay, after spending $34 on the storybook and $12 on some pens, Samad had $4 left. So find the ratio of the total money Samad spent on the 2 items to the money he had left. And your answer must be the simplest form. Okay, now, just to let you know that when I'm doing this lesson, I did not really prepare the lesson. So it's actually my first time looking at the question. So when I look at this question and it looks a little complex, so what comes to my mind? Or what should you think about when you look at something that's complex and maybe not so sure how to do? You should think about, is there any method I can use to show out the problem, show out the solution? So the method that you want to think about is your model drawing. So always think about whether can you draw a model, because if you can draw a model, it helps you to start somewhere. But if you have no methods or you can't think of any methods, then you're relying on your own human brain. And that is, then you have to put in more effort to think harder. But otherwise, if you think of the methods and you use the methods will help you to think lesser because you're applying the methods to help you to solve. So I would like to draw a model and then see how to do this. So let's draw a rectangle, which is a parcel model. So you can see that Samad had some money, and after spending $34 on a storybook, so let's label. So this is your $34 and $12 on some pens. Okay, for some students, you will find that it's quite hard to solve. Right? Quite hard to solve this problem because it looks a little complicated. So what you do? Draw the model. Okay, draw out the problem. And he spent $12 on some pens, and then Samad had $4 left. Okay? Alright, that's the model. It shows out the problem. So find the ratio of the total money Samad spent on the 2 items. So what is the total money that he spent on the 2 items? So which is the storybooks and the pens. So that will be 36. Right? To the money he had left. So where's the left? Which is your $4 left. So your ratio is 36. Okay, 36, which is the total money spent on the 2 items, to the money left, which is 4. So 36 is to 4. And your simplest form, so how do you write your simplest form? You point the arrow downwards and you divide by 4 and divide by 4. And you will get 9 is to 1. So your simplest form is 9 is to 1. So actually this question is quite easy. But honestly, when I was looking at this problem, I was a little unsure of how to do it immediately. So I have to think of a model drawing. Okay, and then through the model, then I start to know how to do already. Okay, so let's go to question 28. Okay, question 28, and it gets a little harder, or maybe. Jared used blue and yellow balloons, and the ratio of the blue balloons to the yellow balloons was 5:7, and he used 156 balloons altogether. So how many more yellow balloons than blue balloons did Jared use? Okay, looks quite simple. Alright, it's easy. So when there's a ratio problem, you label the ratio. So let's label blue is to yellow, 5 is to 7. Okay, so when there's a ratio problem, you label the ratio so that you know what is what. Right, the 5 unit is the blue, the 7 unit is the yellow. And there's a total because he used so many altogether. So my ratio will have a total, which is 12 units. So which means that my 12 units is equal to 156. Then what is 1 unit? Then you divide. You take 156 and you divide by 12. So your 1 unit will be 13. So how many more yellow than blue? Then you compare the yellow and the blue. So that will be 2 units more. So 13 times 2, so you will get 36 more yellow than blue. Alright, so it's a simple ratio problem. But the important lesson here is you label. Every time there's a ratio, it's better to label so that you know what is what. Right, the blue has how many, the yellow has how many. Okay, let's go to the next one. Question 29. Okay, at the fruit store, oranges are sold in packs of 4 and apples are sold in packs of 3. And the cost of a pack of oranges is the same as the cost of a pack of apples. Okay? Alright, so Mrs. D paid $24 for 12 apples. So what was the cost of a pack of oranges? Okay, now this question is going to confuse some students. So what do we do? Now, usually what I would suggest to you is write some simple steps. Read the question carefully. Try to write down some important things. Like for example, oranges are packs of 4. So you can just write down some one packet. There are 4 oranges. Write down something like this, so that you break down the problem into something easier that you can see. And then apples are sold in packs of 3, so maybe I just put 1 packet. Pack means 1 packet of 3 apples. Okay, so you do something like that, and you can see that 1 packet of orange is the same as the cost of a packet of apples. Alright, means they are the same, right? So they are actually same, equal, right? Same cost, right? Same money. So Mrs. D paid $24 for 12 apples. Okay, 12 apples. Okay, let me just draw a line here. So if there are 12 apples, then how many packets are there if there are 12 apples? So if there are 12 apples, that will be 12 divided by 3, you will get 4 packets. Okay, 4 packets. Okay, right? And if there are 4 packets, then how much is that? Alright, so Mrs. D paid $24 for 12 apples. Okay, so it means that 4 packets will be how much? 4 packets will be $24, right? Okay, he paid $24 for 12 apples. Okay, 12 apples. So then how much is 1 packet? 1 packet must be $24 divided by 4, so your 1 packet must be $6. Okay, alright, and if 1 packet is $6, the cost of 1 packet of orange is the same as the cost of a packet of apple. So which means that 1 packet of oranges must also be the same price as 1 packet of apples, right? So how much is 1 packet of oranges? So 1 packet of oranges must be $6. So it's actually quite simple, but it can be quite confusing. Alright, so what do you do? Okay, let me just run through again. Now Mrs. D paid $24 for 12 apples, right? Okay, so let me just write like this. Okay, let me just erase all these for those who are still confused. Okay, let me just explain again. So Mrs. D paid $24 for 12 apples. Okay, 12 apples, $24. So how much is 1 packet? So 1 packet will be 24 divided by 4. So you will get 1 packet, which is $6, right? And if 1 packet of 3 apples costs the same as 1 packet of oranges, then your packet of orange is also same price, which is $6. That's how you get your answer, $6. Okay, so quite easy actually. Okay, let's go to the last question. Question 30, model drawing. Right, your container and contents model. So what does that mean? A pail weighs 9 kg when it's filled with liquid X. There's a container which is called a pail, and the contents is called a liquid X. So when you have container and contents in the problem, then you have the model which looks like this: container plus the liquid X, and you have a rectangle, and you cut it into 2 parts. So the first part is the mass of the empty pail, and the second part is the mass of the liquid X. And both the pail and liquid X weighs 9 kg. And the same pail weighs 15 kg when it's filled with liquid Y. So same pail, but this time there's liquid Y inside, and the rectangle is much longer because the total mass is bigger. But it's still the same pail, so you cut the same box in front. same pill, right? This is the same box, which is the same pill. And liquid Y is twice as heavy as liquid X. So it means that over here, I can call it 2 times or 2 units. And liquid X will be 1 time, 1 unit. So what is the mass of the pill when it's empty? So where do I put the question mark? The question mark is over here. And that's the model. That's called a container and contents model. Alright, so how do we use a model to solve? You cannot add everything together because like what I mentioned in my earlier lesson, there's no total given to you. So if you cannot plus, then what do? You have to minus. So you minus to find the difference. You look at the units and you find the difference. 2 unit minus 1 unit, you get 1 unit. Then you find the difference between the whole numbers. So 15 kg minus 9 kg, you will get 6 kg, which is 1 unit. And if 1 unit is 6 kg, then what is the mass of the pill? So 9 minus 6, the mass of the pill will be 3 kg. And that's how your answer is 3. Alright? So that's the end of our paper 1 lesson. So the entire paper 1 for P5, the standard of this paper is okay, it's quite good. Not too easy, but it's also not very hard. So I think it's quite a good paper. So this is how you do well for your paper 1. You have to know your basic. So you have to understand the different topics, the concept and the basic, like how to simplify the ratio, how to multiply fractions, how to plus and minus fractions. So all these topics, all these concepts, you will be tested in the paper 1. So what is a good way to benefit from the lesson? Like what I mentioned, you will have to do the paper first. You have to attempt to do the papers, the questions, and then once you have completed the paper 1, then you watch the video and see whether your answers are correct, and then you revise. Okay, look at the explanation to see how to revise your mistakes. Alright, so that's the end of our paper 1 lesson. So stay tuned for some more lessons to come. So I'll be posting more lessons on paper 1. And also in the weeks to come, I'll also be posting some heuristic lessons, lessons that you can, lessons on methods that you can apply to solve difficult problems. Alright, so stay tuned for the next lesson. And before that, if you are keen, alright, if you find that the lesson is beneficial, then I will encourage you. Okay, I will encourage you to subscribe to my YouTube channel. So click on the notification bell button, and every time I post a lesson, you'll be notified of any new lessons. Alright, so subscribe to my channel, and then you will get to receive more lessons. Alright, so see you in the next lesson.